Hi, this is the Missouri University of Science and Technology ACI Student Competition Team. And this is our submission for the Fall 2020 Concrete Solutions Competition. Today, we'll be presenting on a new idea for a student competition that focuses on floating concrete. We'll focus on how it can be integrated into the competition, how the competition could be judged, how this competition would be valuable to students, and how it could be applied in the real world.
The idea of this competition stems from the concrete canoe design team's competition that they hold where they float a canoe across the water. It's made out of concrete. But in our case, what we would do instead is have students design a structure capable of supporting weight on water. There'd be no restrictions on the size or on the shape of it. It would just have to sustain the maximum amount of loading that could be added to it.
In the judgment category of this competition, we decided that the main focus is to withstand the most without submerging. The cost of each structure will factor into the assessment score as well as the estimation at which weight structures will sink.
When competition rolls around, students will weigh down their piece of concrete in a big tank in the center of the competition room. This will help create a competitive atmosphere for both teams weighing and teams not weighing.
In addition to that, we thought it would be interesting to focus on something research-based, similar to what is done in the mortar workability competition. So we thought one thing that might be interesting to look at is researching environmental concerns. What kind of issues might occur when you put concrete in water? So this could include what happens to the concrete in water, what kind of structural issues might occur, what kind of degradation might occur, but it could also include environmental concerns, as in what materials might be more environmentally friendly to put in a water-based environment. This would help students to ask and answer some bigger questions that would help them to consider what they might need in the future or on future projects that they work on. This can be presented in a poster format so that they could showcase the work that they have done and what they think is the biggest environmental concern.
So our last point is the creative applications of material science. So students would need to consider what materials they'd be using in their floating concrete. For example, this picture is of a past ACI bowling ball competition, and you can see here that we have used small styrofoam beads. That would have been to keep the density of the bowling ball low and to keep the weight down. Something similar could be used in a piece of floating concrete. Other materials that could be used would include glass, polymers, fibers. So really any other types of materials that students could experiment with. This would help students greatly because they'd be learning new ways to use and understand the materials that they may have thought they already knew how to use in the past. But now they'd be coming up with brand new ideas and brand new uses. This would also be relevant to the real world because there are things that students might be working on in the future, such as houseboats, floating foundations, even floating windmills. Students would have some idea and some creative idea of how to further their work in the real world using this competition. So again, this is the Missouri University of Science and Technology ACI Student Competition Team, and this has been our presentation on why a floating concrete competition should be implemented in the future. Thank you very much for listening.